The electrons of different types of atoms have different degrees of freedom to move around. The outermost or valence shell electrons in a copper atom is very easy to remove. With some types of materials, such as metals, the outermost electrons in the atoms are so loosely bound that they chaotically move in the space between the atoms of that material by nothing more than the influence of the room temperature heat energy. Because these virtually unbound electrons are free to move about their respective atoms and float around in the space between the adjacent atoms, they are often called free electrons. In other types of materials, such as glass, the atom's electrons have very little freedom to move around. While external forces such as physical rubbing can force some of these electrons to leave their respective atoms and transfer to the atoms of another material, they do not move between the atoms within that material very easily. This relative mobility of the electrons within a material is known as electric conductivity. Conductivity is determined by the type of atoms in the material, the number of protons in each atom's nucleus determining its chemical identity, and how the atoms are linked together with one another. Materials with high electron mobility, many free electrons, are called conductors, while materials with low electron mobility, few or no free electrons, are called insulators. Here are a few common examples of conductors: silver, copper, gold, aluminum, iron, steel, brass, bronze, mercury, graphite, water with dissolved impurities, and concrete. In general, metals are the best conductors of electricity. A few common examples of insulators are glass, sulfur, rubber, oil, asphalt, fiberglass, porcelain, ceramics, quartz, dry cotton, dry paper, dry wood, plastics, air, diamond, and pure water. The motion of free electrons in a conductor is random, with no particular direction or speed. Electrons can be influenced to move in a coordinated fashion through a conductive material. This uniform motion of electrons is what we call electricity, or electric current. To be more precise, it could be called dynamic electricity in contrast to static electricity, which is an unmoving accumulation of electric charge. The motion of electrons through a conductor is often referred to as a flow. A noteworthy observation may be made here. As each electron flows uniformly through a conductor, it pushes on the one ahead of it, such that all the electrons move together as a group. The starting and stopping of electron flow through the length of a conductive path is virtually instantaneous from one end of the conductor to the other, even though the motion of each electron may be very slow. An approximate analogy is that of a tube filled end to end with marbles. If you put a marble in one end of a marble immediately comes out the other end.
Hi there everybody, this is Bruce again, and welcome to the fourth lesson in this series. We already know that certain materials are able to conduct electrical charge freely through them. They are called conductors. Materials such as gold, copper, aluminium, and even graphite are good conductors of electrical charge. Yet certain materials such as rubber, wood, and plastics are unable to allow electrical charge to pass through them. They are known as insulators. In today's lesson, we will develop a theory which will allow us to explain why certain materials are able to conduct electrical charge. Can a current pass through any type of material? We can find this out by setting up an electric circuit which includes a piece of the material that we want to test as an electrical conductor. I have placed a light bulb in the circuit so that when the material is a good conductor, the light bulb will glow. In this opening or gap is where I will connect the material that I will be testing. If the material is a poor conductor, then the light bulb will glow dimly. But if the material does not allow electric current to pass through it, the light bulb will not glow at all. I will limit my selection to copper wire, graphite, or what is better known as pencil lead, and a piece of nylon fishing line, a solution of table salt in water, and a solution of sugar in water. It would be a good idea if you could carry out more tests on a wider range of materials to see which materials are good conductors of electricity. However, let's use the materials we have at present and record the results. Here is my first material. I've attached copper wire between the gap, and I will now close the switch. Notice that the bulb is glowing brightly. So, to answer the question, does copper conduct electric current? The answer is yes. Here is my second material. It's nylon fishing line. I now close the switch. Notice that the light bulb is not glowing. So does nylon fishing line conduct electric current? The answer there is no. Here is our third material, which is a piece of graphite, which is commonly known as pencil lead. I will now close the switch. Notice that the bulb is glowing brightly. The answer here is yes. The graphite will conduct electric current. I've now placed two conducting leads into my solution of table salt. I will now close the switch and notice that the bulb is glowing. Yes, table salt is a conductor of electricity. Here are my two conducting leads, but this time into a solution of sugar in water. Let me close the switch. Notice that we do not have any light from the light bulb. So the answer to this one is no. So after this, what can we conclude from this experiment? Firstly, some materials like nylon and sugar solution do not conduct electrical current, while others do. Secondly, those materials that conduct electric current must have charge inside them which is able to move when connected to a battery in a circuit. So there are charges that are free to move inside the salt solution, the graphite, and inside the copper wire. These are called free charges. There are no free charges inside the nylon or sugar solution. These charges inside the materials are not free to move. Now let's use this conclusion to define insulators. We know that materials that are unable to conduct a current are called insulators. From our experiment, we can say that insulators have no free charge within them. Let us now concentrate on the materials that are able to conduct electric current. In particular, let us find out how charges are able to pass through the conductor, like this piece of copper wire. Metals are good conductors of electric current. Apart from silver and gold, copper conducts the current the best. That is why copper is used for the mains cables in houses and all kinds of different motors found in domestic appliances, computers, and telephone wire. Thick copper strips are used for lightning conductors on tall buildings, like church spires. The cable has to be thick enough so that it can carry a large current away without melting. Let us now see how the metallic bond theory explains to us how copper conducts electrical charge. A piece of copper wire consists of many millions of copper atoms packed closely together. This arrangement of atoms is called a lattice. The copper atoms are packed so closely together that the energy levels of their outermost or valence electrons overlap with each other. The innermost electrons are held tightly to the individual atoms, but each copper atom has one or two outermost electrons which are held rather loosely. These valence electrons can break free from their atoms. They can move around freely within the metal. As a free electron moves towards the positive terminal of the battery, the copper atom that has lost that electron becomes positively charged. The atom next to the positively charged atom cannot hold onto its outer electron tightly, and this electron moves to the positively charged atom and towards the positive terminal. This causes the second atom to become positively charged. This process is repeated every time A free electron moves from one atom to the next. In metals, electrons are free to move. Plastics, nylon, and even pure water are made up of molecules in which electrons are tightly held. So it's not surprising that all of these are insulators. Let's now sum up everything we've learnt in this lesson. Free electrons are the charges that move through a metal when it conducts current. In some materials, such as metals, for example copper, charge can move rather freely. These materials can conduct an electric current. We call such materials conductors. In other materials, such as glass, nylon, and plastic, charge cannot move freely. These materials cannot conduct an electric current. We call these materials non-conductors or insulators.